Through my experience of mechanical engineering, there's one thing that I noticed that occurs in every single class, well, practically every single class, is that you draw a lot of triangles, and solving triangles and finding right triangles or just regular triangles is a lot of mechanical engineering. So the basic idea of the Pythagorean theorem is like fundamental to not only engineering but math and science altogether. So today I'm going to show you how to derive the law of cosines, which can be used quite frequently in your engineering courses. So we're going to define not a right triangle, but just an arbitrary triangle. We're going to define it like this. We're going to say we have A right here, B, and we have this angle theta in between them, and we're trying to find the side length C. So for this to work, you need three inputs or three variables, which is this side, and this angle in between them. If you have these three known variables, we could calculate the side length of C, and then you could just repeat the process using the laws of sines, which we'll get through later, to find the other sides and angles and so forth. Well, you don't need to find the other sides when you already have these, but you can find the angles. And then you can use basic definitions of triangles to find the rest. So to get started, we're going to actually define a vertical straight line that goes through that angle but is perpendicular to this bottom line. So by trig, if you know your basic trig, that is a right triangle. So we could say that this is a cosine theta. And then we could say that this is a sine theta, simply because of this triangle right here. Since we know that, and we know this length equals b, we could say that this portion right here, this rest of the triangle, is b minus a cosine theta. So now that we have that, we're going to use the basic idea of Pythagorean theorem. So we have this side, and the hypotenuse is what we're looking for. So we could simply write, so by the Pythagorean theorem, we can write a sine theta squared plus b minus a cosine theta squared equals c squared. So we're going to distribute, or whatever you call it, and simplify this. So a squared sine squared theta plus b squared minus 2ab cosine theta plus a squared cosine squared theta equals c squared. So now I'm going to rearrange this so that a sine squared and a cosine squared are next to each other. So a squared sine squared. I mean, I could skip this step, but I just want to make it so it's vivid, or you can see what I'm doing quite clearly. So 2ab cosine theta. So once you have that, I'm going to factor out an a squared from this. So a squared sine squared theta plus cosine squared theta plus b squared minus 2ab cosine theta equals c squared. So there's a trig identity that says this equals 1. So now we could say a squared plus b squared minus 2ab cosine theta equals c squared. And then this right here is the law of cosines.